All right, Crouton Ramon's House of Math. Going to do a little math here for you. I was talking about this in a couple of posts with some people about working together problems. Okay, first off, easy peasy with fractions. All right, so we have the easy peasy overview that basically shows you what are you doing? You're getting them to get 45 add-ins down and 50, or excuse me, and 400 math facts. Anyway, 45 add-ins, 400 math facts. The math facts, of course, are the multiplication facts. You're going to learn the multiplication facts in math and singing songs and having fun, not by drilling and doing worksheets over and over again. You're going to practice a lot of different math skills by doing problems like this. Let's start off with, okay, so what are we doing here? We're just counting by sevens. So that's always good. Get your multiplication done, but you don't have to have all these. Your prerequisites for doing math here: ability to count to nine, form a rectangle, tell me if something's same or different or not. That's basically the prerequisites. Can they count to nine and tell me if something's same or different or not? Can they identify the difference between a rectangle and a square? Can they see that this thing is red and this one is blue? Probably I can teach them math, or you. And I can teach you how to teach math, because the point here is mathematics. When it comes to the arithmetic is how we do the mathematics. I had a student just recently where some things switched around, and anyway, they wound up having a $400 credit, and they were only going to have one student. So I charged $60, and I asked the student, how many hours of tutoring should his mom get for $400 if the rate is $60? This was a lot of work. Okay, how many 60s in 400s? So what I was asking is, I got four of these, and I want to know how many times I can count. Well, I don't have a 60 handy, so I'll make a 60 with a 50 and a. How many of these can I count out of four of these? All right, well, here it is on paper. And could we make it, just cut these off and talk about how many sixes in 40, which is the same concept as how many 60s in 400? And his first answer was, I don't know. And I was like, yes, you do. You can count. So can you count by sixes? Because we've been counting by sixes over and over and over again. And he was able to count, well, let's see here, 6, 12, 18, 24, 30, 36, 42. And I was like, stop. Can 42 fit in a 440? Nope. So what's the most we can get? 36. And since there's a zero on there, this is 60, 100. And by the way, this amazes little children sometimes, right? I just added zeros. Ah, yeah, yeah, right? Okay, so 60, 120. Okay, so we're going to stop right there. And we're going to say six of them means, right? And this is me just using symbols. Believe me, we've played with blocks. And I can set this up and draw it. All right, so now I have 360 over here. It's not 36 with an arrow, because it's 60 six times. And now I have 40 left. So this client pays absolutely on time, consistently, and has been with me for a while. So guess what? I'm going to make that. We're going to round off, and we're going to give them 7. So there's a concept. So instead of having 6, I'm just going to give them 7 lessons. Which actually, and she's like, "Oh, I'll send you the extra $20 because that's the kind of parent she is." And I was like, "It's fine. We'll just consider it a consecutive week discount bonus because they've been coming for weeks now, and they don't miss." So when we're doing this problem here, I could say it's 60. It's not 61, right? But there's going to be a remainder because let's see here. If I try to put these, so here's what's going to happen. I'm going to have, oops, and I put the 6 in the wrong place. Did you see that? The 6 goes here. It's not 60 times 60. That would be a big number. This is 6 times 60. And see, this was one of the issues I had with some of the Mortensen math books, is they didn't seem to think the place value up here mattered, and actually it does. All right, so anyway, we have now here, I can, if I wanted to, I can do this, and I can do that, and then I could, but you know what I'm going to do? I'm just going to do this. I'm going to say 60, six of them, and we were counting them, what were we counting by? We were counting by 60s, and I had 4 of them, so it's going to be, if I try to remember a rule, and we've done this, it's going to be 40 over 60. Why wouldn't it be, uh, can't, anyway, but we'll skip the problem in the first place. So anyway, it's 6 and 4/6. And then I was going to ask him, we didn't do it, what is 4/6, just for fun, of 60, of an hour, right? In other words, and the child actually got this one where he started figuring out, well, that means that there's 3 of something in here, right? Because 20 or kind of 16, 4/6. He was able to see, well, actually, he started off with there is 10. If I cut by 10, I'd have 6 of them here. And if I cut by 10, I'd have 4 of them here, right? We're reducing because he knew that part, 40 over 60. He knew how to reduce. So what I'm trying to figure out is what's 4/6 of an hour. And the way he did it is he figured out that, well, let's see, if the whole hour is 60 minutes, and then he was thinking, well, half an hour would be 30 minutes, but that doesn't help here. So he finally started thinking, well, let's see, 20, 20, and 20 would be 60. So now I can break my hour up into, oddly enough, 20 minutes, because guess what? There's 60 minutes an hour. I charge $60 an hour. That's $1 a minute. And there are people that charge a lot more than I do. But dollar, and it's $75 an hour if I'm just working one time or a couple of times, and they're paying as they go. But if they buy a flight, it works out to $60 an hour. I have plenty of people that I trained that are charging twice this, so $2 a minute. Anyway, so he figured out that well, 20 minutes. So he would actually should have gotten 6 lessons and 40 minutes of a lesson. But actually, like I said, I just rounded up to 60. Anyway, what are we doing over here? We're doing arithmetic, and the arithmetic is how we're doing division, and that's how we answer the question: how many lessons does $400 get you? All right, let's do some working together problems. Since we've had the inauguration, and everybody's talking about how we're going to work together again, right? So let's just make a simple problem. And we'll make it a painting the floor problem so we can't miss. So let's say one student would take 2 hours to paint the floor, and the other student would take 3 hours to paint the floor. Right? Because usually I have more than one student. But if I only have one student, then it'll be one student. And more to I work slow, but I work steady. All right, so if he took 3 hours and you took 2 hours, and see, this is the great thing here. Let's get this. Can I line it up? Close enough. Let's see. I'm trying to square off the. There we go. They got to face each other, and then I don't want you looking in the other room. All right, can I do it that way? Yes, I can do it that way. All right, perfect. So, if I have one person painting the floor, and I'll tell you what, we'll make this the floor. We'll just pretend this is the floor. Okay, this is a room in my house, and they got to paint the floor. All right, so the one child would take 2 hours, and the other child would take 3 hours. How long would it take them working together? And we're going to assume that they don't get in each other's way, and everything goes perfectly, and so forth. But if they're working together, how long would it take? And so some of them say 5. I know exactly how they got 5, and 5 is not the right answer. But why would it take you longer working together, unless, of course, you got into a paint fight or something and had to clean up? Why, if it only took you 2 hours and him 3 hours? Okay, so then you get parents that'll take it, let's add 2 and 3 and then divide by 2 because there's 2 of them. It's 2.5 hours. Why would it take you longer if you had somebody helping you than to do it by yourself? So then they're saying, okay, well then 1 hour. Okay, that's a good guess. Do you know? No, you're just guessing. But yeah, you're right. If somebody's helping you, it should take you less time. Simple as that. And it should take him less than 3 hours because he has somebody that's faster than him working, right? And it should take him less than 2 hours. All right. So just thinking again, right? We're just thinking about it, logic and reasoning. All right. How about we start doing a little more math and thinking a little more? Um, what do we need to do? This is concept number 5. No fun, get back to one. First thing we need to know is, well, how much do they get done working together? So you should get your blocks out. And actually, wait, before we do this, we're just about to get there. There's a few things that you should do before you get to these kind of problems. You should play a game where this is your solidus, the line, the vinculum, the line between the two numbers when you're doing fractions. And you should play a little game where you have the line and you put a 2 block over here. And, well, actually, you put a 1 block over here. We'll start with that. And you say, every time I get 1, you get 2. So then you put this down in front of them and put 1. How many should you get on your side? Well, they should get 2. And then you go through this and start seeing that if I get 1, you get 2. So if I get 2, then how many should you get? And the answer is 4. 2 twos. And then pretty soon, what if I did give you 3? Well, then you have to give me 3 twos. Or you could just give me 2 threes. Because what does this say? The relationship is 1 to 2. So if I give you, and children see this immediately, by the way, I've been doing this long enough, where if I give them 1 3, then they give me 2 threes. But it's still just I give you 1 of something, and then you give me 2 of something. But these things have names. This is a 3, and this is 2 threes, and 2 threes is the same as 6. Same thing over here, where if I start off with 1 2, 1 2, then you should give me 2 twos, and 2 twos is 4. So it's still 1 to 2, 1 to 2. And of course, with units, 1 unit to 2 units. Why am I doing this? So that we get the idea of equivalent fractions. Because in order to add fractions, we have to make them same. And in order to make them same, we have to know a little bit about equivalency and equivalent fractions. So I know that 1 to 2 is the same thing as 2 to 4 is the same thing as 3 to 6. And then can you do, what would this be? Well, 1 4, then I should get 2 4s. And we have a name for 2 4s, that's 8. And then we can play and start understanding about reducing. And I'm doing the super fast lesson because this would be multiple lessons before you got to this problem. Or you could do this as part of the problem, the way I am now. There's multiple. There's no one way to do it, and everybody wants one way. Let's show us the one lesson. All right, so here it is. There is 1 to 2, and in this case, it's 1 10 to 2 tens. Now I can take. Let's see here. How about I just use an envelope? Yeah. And the envelope has math on it, of course. Anyway, 1 to 2, 2 to 4. And we just go out and we can write them down if we want to. 3 to 6, 4, 7 to 14, 10 to 20. But the relationship, and that's why we call it reducing, is still, it's nice though. OCD people. Oops, can I get even more perfect? Yes, all right. Now, bonk, that 10 to 20 or 9 to 18 is the same thing as 1 to 2. It's the same relationship, 1 to 2. All right, then you do it with, and see, you can teach multiplication this way. You can teach division. Well, actually, let's change that. Okay, there you go. And I gotta get this thing. I need a studio is what I need. All right, so now what we have is lessons in multiplication. And see, now I could do, what if I did something, what if I got crazy with my bad self, and instead of 1 to 2, I did 2 to 3. Now we're practicing multiplication tables. Ugh. It's magic, because I have Play-Doh. Now we're practicing multiplication with 2s and 3s, instead of just 1 and 2. So now I have to multiply, let's see here. For every time I get 2, you get 3. So we'll practice. I get 2, you get 3. I get 4, how many do you get? Well, let's see, you should get 6. If I get 6, how many should you get? You should get 9. But the relationship is just 2 to 3. So now we're practicing 2s and 3s. And you could have them write it out if you want to. But writing is, again, if it's a little child, the writing is not reflective of their intelligence and their understanding. It's reflective of their fine motor skills, which may or may not be developed. All right, 2 to 3 is the same as 4 to 6. I can count it, I can see it there. It's the same thing as 6 to 9. And all of those, that is, what is that? That's 2 3s and 3 3s. That's 2 2s and, right? Okay. That's why our students have better understanding than children that just play around with symbols and never see a block and never get their hands on any manipulative. Okay. So you play around with those first, so that now when I do this part, it's easy. But what's the goal? 45 add-ins, 400 math facts. That's the goal. Okay. So let's get rid of this. And I'm going to draw this now. There's my floor. We're back to this. We're painting the floor, and one person takes 2 hours, the other person takes 3 hours. And this is the one where this poor guy was doing a Mortensen math presentation at a homeschool convention, and he screwed up at the end. And I had to correct him. I couldn't stand it. He couldn't, because I wasn't going to allow him to be representing Mortensen math and teach math the wrong way. Okay. Yeah. Okay, so these are supposed to be equal floors. All right, there you go. Now, how much does this guy get done? Well, in 1 hour, he would get done. This is the no fun get back to 1 part. In 1 hour, he would get half the job done. Takes him 2 hours. You get 1. And then this guy, Mooey, the moo cow, taking longer and fooling around, it would take him 3 hours to get the floor painted. So in 1 hour, this would be a representation of how much he got done. Now, if you have the pieces, great, get them out and use those. If you don't have the pieces, a drawing is fine. And what pieces am I talking about? I'm talking about fraction pieces. You can get them anywhere. Mortensen has them. Matthew C's pieces are exactly the same. There's a bunch of them that are identical to these. And then there's some out of Hong Kong or Singapore or someplace in Asia where they're expeller or extruded. They're injection molded, and I very much like those pieces. Anyway, can I get this thing to do what I want? The answer is yes, I can. Okay, good. Now, so here's your floor, and now I can represent this just like this. Oh look, you got half the floor done. There's 1 hour, right? Now here's the other guy. Look, we can add them together, and we can see. Not much use for imagination here. We can literally see that it doesn't take very long for them to get the floor. But, right? It's going to be 1 hour and some more. Right? 1 hour and a little bit more. How much is this little bit more is going to be the next question. All right. So, I'm going to represent this like this. 1/2 of it got done. 1/3 of it got done. And if they were working together, Democrats and Republicans, cats and dogs, sleeping together. How much would they get done working together? Well, here's the problem. They're not same kind, so I can't add them. So now I have to make them same, which is why we played the I get 1, you get 2 game. Because now I can see that if I want to add these guys together, there's an easy way by just putting an overlay on these guys. If you can go watch a fractions video about that. Or I can look at these and see that, well, actually, I'll do it fast. There is 1/2, clearly. Now I'm just going to put this overlay on it quickly, and there's a whole lesson on the way to develop that, too. But, oh, can you see that now I have 3 of 6? Can you see that? Yep, the colored ones are 3 of 6. Okay. Now, I'm going to do the same over here with my third. So here's my 1/3 of the floor painted, and I can bust that into thirds like this, so I can see it clearly. You see how fast it is just to draw it? But to get them manipulatives out, it really makes a difference to get their hands on it. And then, let's see, I can put this on there. Oh, look, it's now 2 of 6. I skipped a whole bunch of steps to get here, but I can see, right? Now, this is the same thing. And later on, when we started doing these, he was able to figure out the denominators very quickly. And for some children, this is the first time they've ever seen fractions. You have to explain to them numerator, denominator, solidus or vinculum, right? Solidus, vinculum. Oh wait, it's the other way around. Okay, so here is 3/6 is the same as a half, and 2/6 is the same, and the child immediately went 5/12. Oh, wait a minute, hold on. If you have 3 of the 6 kind and 2 of the 6 kind, how many do you have together? You get 5 of the 6 kind. We're counting 6 kinds. And the way you explain that, 1 of the 6 kind plus another 1 of the 6 kind, certainly that's easy. That's 2 of the 6 kind. And you can get your guys out, your manipulatives, and you can see, look, I'm just saying this is 1/6, and this is another 6, and I'm going to have 2/6. That's easy. Because sometimes what happens, which is problematic, is they'll say, okay, I've got 1 of the 3rd kind and another 1 of the 3rd kind. Let's change these 3s. And so if I have 1 of the 3rd kind and another 1 of the 3rd kind, what do I get? Do I get 2 of the 6 kind? Well, that makes no sense at all. I have 2 of the 3rd kind because these are 6. And how would I add 1 of these and another 1 of these and get 2 of these? And see, any child will go, oh, right? Because it's visually obvious. It's a Montessori term. When I'm using manipulatives, it's not so visually obvious when I'm just using symbols. Okay. So, and again, you don't need to know. You just, let's take a look at that. Let's examine that. Let's think about it. Could it be that 1/3 and another 3rd would be the same thing as 2/6? It can't be. Right? You don't have to say, no, that's not right. Just, let's look at it further. All right, so now I have 5/6. So here's what I'm going to do. I am going to change my floor from a square like this to make it easier. I'm just going to change my floor into 6. So here is my floor now. I made it a long, skinny floor. All right, and I have 5/6 of it done. Do you see that I have 5/6 of it done? Now, do I need, this is 1 hour. In fact, let's break it down. This is your student and Mui working together, right? So actually, the student would have got, there it is, half the job done. There's Mui. He would have got 1/3 of the job done. Well, I can put it by himself if I want to, and we can see that it's 1/3. All right, so working together, they would have got this much done because 1/2 plus 1/3 is going to be 5/6. There it is, look. Right? So now that's not just a pink block and an orange block. This is your student and this is Mui. And this is them working together. And this is the whole job. All right, so now here's where the guy messed up. Is that then he said, well, then what's left? Well, you're right. It is 1 out of the 6 left. But that's not what we're counting. We're counting these. So if you put down the answer is going to be 1 and 1/6, there's no debate. I don't care how you feel. Um, I'll stop there. This is just wrong. Okay, what we're doing is we're counting how many of these are contained in this. Right? So, and I've seen some tortured explanations for why suddenly you have to make it 6/5. Right? Because what are we doing? We're counting, we're comparing these two. Right? So now, how much more of that hour do I need? Do I need the whole hour? Any little child can tell you, no, you do not need the whole hour. What part of the hour do I need? I need one part of that hour. And what is our hour? Our hour is a 5, not a 6. Right? So it's 1 hour. This would be 2 hours. Oops, but we don't need 2 hours. We need 1/5 of that hour. We're not talking about this. There was a slight argument, but very quickly it became clear that the correct answer would be 1 and 1/5. Now we like 1/5 because 1/5 is easy to figure out. Well, how many minutes is 1/5? Well, if I know there's 60 minutes an hour, we never say that it's, that job will take. We basically break it down to like halves, maybe quarters, but we don't say fifths, and we don't say sixths, and we don't say, 12th of an hour. We never say that, right? 12th of an hour, 5 minutes. All right, but what's 1/5 of an hour? Well, that's just 60 divided by 5. If you know your multiplication tables, that answer is super easy. How many fives are contained in 60? It's 12 minutes. So it would take you about 1 hour and 12 minutes if one person took 2 hours and the other person took 3 hours. It certainly wouldn't take you longer than 2 hours if you had somebody helping you, and it certainly wouldn't have taken you longer than 3 hours if you had somebody helping you. Of course, it took you less, and in fact, it took you about 1 hour, and so about half the time. Even though this guy's slow. Right? And we did a few more problems. Let's do a couple more problems quickly. And I can assure you that after 1 hour, I've done this numerous times. After 1 hour with students that understand some basic concepts here, they'll do these so fast. By the time I write them down, they're already shouting out the answer or jumping up and down with their hand raised because they know the answer. Because what do? They'll very quickly, and I'm only telling you this. You don't tell your students this. Let the students figure it out for themselves. But what they'll very quickly figure out to do is, let's see, multiply these two together, then add them together, and then divide. They'll do this in their heads instantly once they know what they're doing. So then when they see a question like this on a test, they get it instantly. It's a gimme. They're happy. All right, let's change the problem. Let's say that it takes one person 2 hours to do the problem. And once again, what's the goal of this? Well, they get to practice their fractions, they get to practice their multiplication, they get to practice their addition, all by just doing a story problem. All right, let's change it. Let's say it takes Mui to Mukau, and he's going to be a total slacker and fool around and so on. And instead of it taking him 3 hours, this time it's going to take him, let's get crazy. It'll take me 5 hours to get that job done. Best I can do is 5 hours. 5 hours, best I can do. All right, so this guy's going to do 5. Dear. Now, so I'm going to have to break this into 5 pieces. Can you get and see how much faster it is to just grab a manipulative and grab your fraction tile? Anyway, so now this guy will get it done, half the job done, and this Mui to Mukau fooling around only gets 1/5 of the job done. Because it's going to take him 5 hours to finish the same job. All right, now, by the third one of the students I was working with understood that immediately, the denominator, the common denominator was going to have to be 10. But if not, there's a bunch of ways you can walk your way up to that. That 1/2 is the same thing as 2 fourths, 3/6, etc. 4/8, 5/10, 5/10. And this one, what's the next one? It's going to be 2/10. So let's see here. So over here we're going to have 5/10, and over here we're going to have 2/10. And again, if you need to, go back and play with your slider can see, I'm about to get some blocks from Hawaii or someplace because these are old, and could get some newer ones that aren't quite so. These blocks are older than a lot of you guys watching this. Promise. Anyway, and you can be 40 years old, and these blocks are still older than you. Anyway, let's see here, and you can still use them. Buy once. Okay, so 1/5. Oops, okay, and then I'll slide it over. Oh, 2/10. 3/15. Well, actually, we just need 2/10, but 3/15. 20. So on top we're counting by ones, and the bottom we're counting by fives, and that's why I went to five, because fives are easy to count by. Degree of difficulty. All right, so 5/10 and 2/10. Well, then now I'm going to take my floor and I'm going to break it into 10 parts. And instead of it being a rectangle, a square, I'm going to make it into one long, skinny rectangle. Can you see that okay? Okay, so there is my floor in 10 parts. Here is your student doing it. He gets 5, right? Gets half the job done. And then this guy gets 2/10. So if we're going to be putting them together, let's see here. 5 of something and 2 of something makes 7 of something. There it is. But it's not just 7. It's the 5 and the 2. Right? You guys working together. Okay, so now what's left? Well, that's easy. Especially if you know your add-ins. There's going to be 3 there. Now, is it going to be 1 and 3/10? That's ridiculous. Because what are we counting by? We're counting by sevens, right? Sevens is 1 hour of work with these guys working together. So now I have 1 hour, and now I have another hour, and I need 3 out of that 7. So this would be 1 and 3/7. Because if you put the answer to the question, if they're working together, 1 hour and then 3/10, again, no debate, you're just wrong. You just don't understand some basic concepts in mathematics. All right, so the right answer would be, so I'm going to work these guys together, 7/10, and from there I understand that I'm going to have to take 10 over 7, because I'm counting how many 7s are in that 10, and get 1 and 3/7, because we're counting. Oh, look, now we get to practice fractions, we get to practice mixed numbers, we get to practice converting, we get to do some multiplication, right? We're doing math. We're practicing math. The point of it isn't so much the story problem as being able to practice your math skills. And what are the skills that we're working at? 45 add-ins, 400 math facts. And the way we get there, tell some stories, some story problems. You can find this problem in the Series A manuals. Get yourself a password. It's all lessons like this and more are behind paywalls. Oh wait, I didn't finish. So what did I have? I had 1/2 plus 1/5 was the same. And see, can you see with students, any student, that if you didn't do all the work, and I've seen math teachers do this, and they just tell you what the answer is, that because they can do it in their head quickly, right? Because they know something about this and this and this and this, and I'm telling you that is really going to confuse your children. And if they forget the rule, they're going to have a bad time. So teach them concepts instead. So anyway, 1/2 plus 1/5. What do we have to do? Well, that means that I have to make this into 2/10, into this one 5/10, and this one into 2/10, and then we add them together and get 7/10. And then when I invert, because I have to figure out how many 7s are in 10, because I'm trying to figure out how much they get done working together, I get 1 and 3/7. And now, what in the heck is 3/7 of an hour? Now it's some work. And if you've got little children, skip it. If you've got older students, you may want to do this. Okay. So, let's do it. Let's do this thing. What do I have to do? Well, I'm trying to take 3/7 of 60. That means I have to take 180, because 3 times 6, and then what is this? 1. We're doing multiplication here. So that means, oh my goodness, let's go over here. Then I have to figure out how many 7s, and that's why you saw when we very first began, there was 7's multiplication table here. How many 7s in 180? Well, one student, and the student was 6, knew that it was going to be more than 20 because he knew that 20 times 7 was 140 because he'd done that much of his multiplication tables. Well, let's see here. Can we figure out how many 7s in 180? Well, let's see here. Um, if you know something about this, you could draw this, or you could just take 2 of them, right? 20 of them, actually, and that would be 140 because this is 20. Once again, place value important. And I had there are some Mortensen math books that still, they put the 2 over here, or anyway, it's, place value is actually important here also, because that is 2 10s, not 2 hundreds and not 2 1s. And 2 10s times 7 is 140, not 14 with an arrow. That is a personal pet peeve of mine, because it completely, right? The dumbing down is not an accident, my friends. All right, now what's the most 7s I can get out of 40? Well, if I know that 6 times 7 is 42, well, that's too much. No, 5 times 7. So that's 35. And I have 5 left. So 25 minutes about. Do you want to do the seconds? We'll just skip it right there. We'll stop there. So what's it work out to be? It works out to be 1 hour and about 25. Well, we can do that. We'll write it the way 1 hour, 25 minutes, and some seconds, and we don't know. We didn't calculate the seconds. We could. What's 5 seconds, right? Because what are we going to do? Now we're going to do 5/7 instead of 3/7. We're going to do 5/7 of 60 and do the problem again, and then we can figure out seconds. But the seconds really are going to be that didactic. Okay, but there it is. I should do 3. Right? First time, huh? Second time, oh, okay. Third time, we've already done that. All right, so pick 3 problems. All right, so and again, degree of difficulty: 2 and 3, 2 and 5. Why? Because 5s are easy to count by: 5, 10, 15, 20, 25, 30. Right? In the middle of doing this, you could take a break and watch some multiplication rock videos or other math music videos if you have any that you like. Or you could pop in a tape from Jerry Mortensen and listen to those multiplication rock songs. Well, they're not really rocking, but Jerry on his synthesizer playing and singing songs about numbers. Let's do one more, and now let's not start with half. Let's say, okay, this is kind of a big job, and one person. Okay, and now we're going to go up the degree of difficulty. You would have done a lot of problems and then fooled around a little bit more before you did this third one. And again, I can say numerous times by the end of the class, and if a teacher comes in at the end of the class and I put a problem on and the kids are answering instantaneously, they're shocked and amazed, and I'm some kind of crazy magician. No, we just have a methodology that works. 1/3 plus, let's say, wait. I'm getting way ahead of myself. Okay, one person does the job in 3 hours, and the other person does the job in 7 hours. 2 multiplication tables that you have to go all the way to 10 before it repeats. Right? Both of these. But this is a lot easier than this one. Okay. So if you don't have a confident student, you probably don't want to throw a 7 in there. You want to throw 3s, 5s, 4s, right? 2s and, right? Okay. Just talking about degree of difficulty. All right, so this person gets it done. And I'm just going to draw it. I'm not even going to get manipulatives out this time. And see, and as you do more and more, less and less drawing, more and more symbol, right? Because what's the thing? What? You start in the concrete. Then you move to drawings. And then last is your symbol. And that's when you get the compound lesson, you get the understanding, you get the meta learning. I usually just put understanding. That's what that says, understanding. Concrete, drawing, symbols, understanding. Right? Now, a lot of times you have to go from, you start with symbols, obviously, and then move to the concrete and go to drawing, but you're going to use these 3 And a lot of people only do two of these, right? They do, right? You don't want to just do symbols and drawings when you're starting out. You want to get hands on blocks, hands on manipulatives. Oh, look, this is I can hold a half in my hand. And I can see that a half and a third, right? If we'd had this, you would have been having cheap third of a pounders instead of quarter pounders. So you still get quarter pounders. You know why you get quarter pounders instead of third pounders? Is because people thought that a true story, and you all know it, that this was bigger than this. Can you see that this is not bigger than this? All right. See, that's the thing. Can you see it? Yes, it's visually obvious. But if all you know is that 4 is bigger than 3, so it must be better, you wind up with a populace that will pay more for a quarter than a third. They'll also stand on stickers reeking of hand sanitizer because they've been told to, wearing their face diapers, quivering. Okay, there's that. There's that. I gotta make 7. Can I get 7 in there? 1, 2, 3, 4, 5, 6. Yeah, see, can you see these guys? I'm gonna get rid of that and make this into 2 lines instead. Okay, there you go. Now, when they work together, one guy gets 1/3 done, one guy gets 1/7 done. How much do they get done working together? Well, now we got to add them, right? This is the no fun, get back to 1 again, right? How much do they get done working in 1 hour? All right, now the student looks at that and goes, must be, what's the common denominator going to be? It's going to be 21. Oops, that's not okay. If they can see that, great. If not, like I said, walk your way up there. Take the overlays and put it on there that 1/3 is the same thing as 2/6 is the same thing, etc. And then over here, 1/7, 2/14, 3/21, right? And over here, you're going to walk up 7 times to get to, what am I going to have? I'm going to have 7/21 and 3/21. And then I'm going to wind up with, oops, an equal sign, 10/21. So they're going to about half the job done in 1 hour, right? But then they're going to need 2 hours and then 1/10 of an hour. And that I will actually get my blocks out to make sure that you have under. So what do? We figured out that the floor, now we're going to have to cut it into 21 parts. So here's my floor. And see, now it's fun because you got to measure. Look how long this is, right? And then there's actually a 1 on this even. Right? Okay, so stick it on there. Actually, I'm going to do that. Let's take a moment. You can watch this on 2x speed or hit the fast forward button. Play-Doh break. Gotta get the Play-Doh. All right. There's that. Plenty of space for 21. Is it going to fit that? Yeah, it'll fit right there. All right. 21. And then another piece of Play-Doh. And I get my second one on the, and now I gotta put my unit on the 1 unit, scooch. And now how am I gonna measure this 21? I'm gonna measure it by 7. This is also a thing you should have done previous to this anyway. Take some stuff, lay it out, measure it with 7s, measure it with 2s, measure it with 5s, measure it with 6s. And then before you start measuring, ask the student, how much do you think, how many times do you think it'll go? Right? How many 7s do you think would be in 21? I know there's 3. How many 3s do you think would be in 21? Okay, so anyway, there's this person. And now I gotta get a 3. Which is, put them away. Need a 3. And that's 1 hour. Okay, so they didn't quite get half the job done, almost half the job done. And then what? Then we need another one of these. The guy, and then Mooey the Moo Cow being silly. So there's two of them. And now we can see, do we need 1 out of 21 or do we need 1 out of the 10? Well, we need 1 out of the 10. So I'm going to have 2 of these and 1/10 of these. So the answer would be that this job is going to be, oh, well, let's just do this first. What's 7 21st plus 3 21st? Well, that's 10 21st. And now we're going to have to figure out how many 10s, oops, the other way around, how many 10s in 21, which works out to be 2 and 1/10, not 2 and 1/21st. Because I'm comparing that 1 to the amount of time it takes me to do the job, not to the whole job. Okay, what's 1/10 of an hour? Well, that's super easy, happily. 1/10 of an hour, 16. So basically 2 hours and 6 minutes. There's your final answer. Okay, there's 3 of them. Do more of these, right? This would be a much harder problem. You wouldn't throw this at a 6-year-old. Keep the numbers small and easy. Once they get confident, though, not a problem. They can knock these out quickly. Like I said, at the end of a class, I think it was, what was it, 6th graders, I think. By the end of class, by the time I wrote the 7, somebody was shouting out the answer. Right? Because they knew. They're just waiting to see what are they going to do. They're going to add these 2 guys together, right? And then they're going to multiply these 2 guys together, and then they're going to do the division. So they were doing this in their head. They just added these 2 guys together, multiplied, got that number, and then did the math. And the brain is a supercomputer, can get it done instantaneously, faster than you could punch it into your calculator, or even if you had an interface like a computer or something that you were, Wolfram Alpha, and you were putting the data in. The mind can do it faster. They don't want your mind trained like that. They don't want you able, and certainly not the entire populace, able to do mathematics. Because then a lot of people failed algebra, which means you never got to statistics, which means they can fool and lie to you with statistics all day long. And they did. And people died because of it. The math is kind of important, people. Like, you don't understand why I'm on the crusade. If you could do mathematics, things would be different, right? If the populace was able to do mathematics quickly and easily, things would be completely different in the United States of America, which is why they don't want you understanding mathematics, and certainly not as a mass or as a group. And that used to be crazy conspiracy theory, but now some people are starting to figure out that that guy might not be as crazy as we thought. Anyway, still working on my website. The new goal is July, because I think I'm going to wind up at the homeschool convention, and I want to have it done by then. I thought I'd have it done by now. I was sure I'd have it done by January. No. Anyway, for now, it's still $500. That's the sale price. It's moving up to $1249. Go look at my website and figure out what the heck it is I'm talking about. But it's going to be $1249 soon. And you can start seeing that some of those web pages are looking pretty spiffy and pretty cool. And then eventually the website's probably going to get migrated onto another site in a slightly different format, because people keep teasing me because my website looks like it was built in the 90s. It wasn't. It was built in the 2000s, but it's still, we've come a long way in the last 15, 20 years. And I could probably update my website, but I kind of like it the way it is when you get down to it, because I can't make it any more plain. Go look on the toolbar, and you'll see addition, subtraction, multiplication, division, and so forth, and all the over here, right? So look at the toolbar. It is pretty much in order. Algebra, problem solving, etc. All manner of lessons. But anyway, for $500, you get behind you get behind all the paywalls, you get the algebra course, you get everything for $500. Soon we're going to be piecemeal, and you're going to see that just teacher training is going to be almost $500. And in fact, the teacher training is going to be more than $500, because you can turn around and make money doing this. The demand for math tutors and teachers is off the charts right now. Everybody thinks that they can teach history because they'll regurgitate the history that we were taught, which we're starting to find out may or may not have been correct. Everybody is sure they can teach English, and for the most part, you don't teach them what the words mean, but we'll skip that part too. But everybody panics when it comes to mathematics, so they want help. So if you have the inkling and you would like to help others, get my passwords. And I can tell you, Laura Lazenby can tell you. She lived down there in Provo. I'll mention her name. That was a math phobiac to the max. And she wound up making a career out of it for a little while there. Paid house, paid car, paid everything comfortably. And all she did was play blocks with kids. You can too. You too can play blocks for fun and profit. Okay, I think that's going to do it for this one. Crouton Ramon's HouseOfMath.com for more.